Unit number 1 is conductive materials. Contents: conductive material. Second, general properties and specification of conductor. Third one is the factor affecting on resistivity. Fourth, thermal conductivity of metals. Fifth, conductor bimetals. Sixth, types of fluids. Seventh, electrical carbon materials. And eighth, superconductivity. Next is the introduction. Here, the most important properties of metals are their high thermal and electrical conductivity. Silver has the highest electrical conductivity, and copper comes next, and it is similar to the silver. From the point of view of atomic structure, the supplies of copper is not present in a great quantity. The aluminum, which is light in weight and it has high conductivity, and it is more important as a conducting material. The gold has high conductivity than aluminum but lower than silver and copper. The gold has no use in electrical industry because it is so expensive. Next point is conductive material. There are various types of conductive material. Firstly, we will see copper. The copper is used in various electrical applications. The pure annealed copper is used for winding of electrical machine. So firstly, we will see what is the annealing process. The annealing process, it is the process that change physical and sometimes change the properties of material to increase the ductility and reduces the hardness to make it more workable. The purity of copper is obtained with the help of electrolytic refining. The conductivity of copper is decreased when it is hard drawn into wire for use of machines. The annealing process is used before material can be used in a machine. The hard drawn copper is having high mechanical strength compared with the annealed copper conductor, and it is used in low voltage distribution lines. The long span lines required a conductor having high mechanical strength, which is achieved by adding cadmium to copper. The cadmium increases the mechanical strength of the copper without affecting its conductivity. Copper conductor is having steel core are employed for long span transmission line. Next conductive material is tungsten. Tungsten has highest melting point among the metal. It is therefore suitable for the applications requiring high operating conditions such as a lamp and filaments. The resistivity of the tungsten material is 5 microohm per centimeter. The great hardness, high boiling point and high melting point of tungsten coupled with its resistance to abrasions. Resistance of abrasions means resistance to wear, and it is also mean by scratch resistance. The typical operating conditions of tungsten material, the voltage AC or DC up to 230 volt, the current is up to 15 ampere. The typical applications of tungsten contact are in battery ignited system, vibrators are in electrical razors. Next conducting material is carbon and graphite. In DC machines like generator, motor, the sparking problem is very severe, and the wearing of commutator is also the severe problem. This severity is reduced with the help of carbon and graphite brushes. The carbon material is also used in automatic voltage regulator. The other use of carbon material is making arc welding electrode, fixed and variable resistance for light current applications. The resistance temperature coefficients of carbon material is negative. Next material is iron and steel. Steel is employed in railways applications for its cheapness and rigidity. Galvanized steel and iron wires, which are generally used for earth conductor in low voltage application system. It may also use as a phase conductor in rural areas where cheapness is the main consideration. Such lines will have large voltage drop because its high resistance and inductance. The steel alloyed with the chromium and aluminum is used for making starter rheostat, where the lightness combined with the robustness and good heat dissipations are important considerations. The cast iron is used in manufacturing of resistance grids to used in starting of large DC motors. Next material is nickel. The nickel is widely used for making electrodes of thermionic valves and sparking plug. It is also used to form positive plates of nickel ion batteries. Next material is lead. The lead has two important applications in electrical engineering. It is used to form cable sheet, and second application is plates of lead acid battery. The lead sheets are required to protect the insulation of cable from the effect of moisture. Next material is tin. The important electrical use of tin is in manufacturing of low current fuses. Next material is alloy. Alloy materials are used for making resistors for laboratory instruments and for laboratory standards, where the high consistency of resistance is required. They are also used for making heater thermocouple element. The important alloys are Eureka, Magnenin, Nichrome, etc. Next conductive material is aluminum. Aluminum conductors are particularly suitable for operations in very high ambient temperature. The use of aluminum as an electrical material, particularly in aircraft industry, because saving of weight is involved. The current carrying capacity of aluminum is 75% of copper, and its current density is 1/3 of copper. The weight of aluminum is half compared with the copper, and current carrying capacity of aluminum equal to the copper. So the weight of the cost of the aluminum is less than the copper. Steel reinforced aluminum conductors, that is ACSR conductors, are widely used in long span transmission line. The commercial form of aluminum is obtained with the 99% of purity. Generally, it is alloyed with the small quantity of copper, zinc, nickel, magnesium to improve its hardness and strength. The aluminum conductors are not easily solderable, but it is solderable with the help of fluxes. The mechanical clamping and screwing method have been also developed. Next point is factor affecting on resistivity. There are 4 factors which are affecting on resistivity. First, temperature. Firstly, we know what is meant by resistance. Resistance, it is the opposition to the flow of current. There are 4 factors which are affecting on resistance. First is the length. The length of the material is directly proportional to the resistance of material. The cross-sectional area of a material is inversely proportional to the resistance of material. Third factor is type and nature of a material. If the material is conductor, its resistance is less. If the material is insulator, its resistance is high. Next parameter is temperature. As temperature change, the resistance of material is change. From these four parameter, we can write one equation, that is R is equal to the rho L by A, where R is the resistance of material, L is the length of the material, and A is the cross-sectional area of material. The specific resistance or resistivity of material depend upon the nature of material, and it is measured in terms of ohm per meter. In case of metal, if we increase the temperature of a metal, inside the metal the velocity of atom is increases. Due to this, the collision of electrons with the atoms is increases. Due to this collision, the temperature of metal is increases. Due to increase of temperature, the resistance of metal is increases. So such types of metals are called as such metals are having a positive temperature coefficient. The resistivity of semiconductor and insulating materials decrease with increase in temperature. Such insulators and semiconductors are called as a negative temperature coefficient. Next point is alloying. Alloying is the solid solution of two or more metals. Alloying of metal is used to achieve some mechanical and electrical properties. The atomic structure of solid solution is irregular as compared to the pure metal, due to which the electrical resistivity of solid solution increase rapidly with electrical alloy content. A small content of impurity, it may increase the resistivity of metal. Point is cold work. Cold work is a manufacturing process used to increase the strength of metal. Cold work disturbs the crystal structure of metal, which interferes with the movement of electrons in metal, due to which the resistivity of metal is increased. Next point is hardening. Edge hardening is a treatment which used to increase the yield strength and develop the ability in an alloy to resist permanent deformation by external force. This process increases the strength of alloy by creating solid impurity, disturb the crystal structure of metal, which interrupt the flow of free electrons through metal. Due to this process, the resistivity of metal is increased.